We saw how weighted mean is sometimes better than usual mean. Well, the next measure of central tendency that we are going to discuss is an extreme application of this idea. It just gives zero weights to some of the points in order to achieve robustness. It is called the trimmed mean. We have seen that mean is not very robust because extreme observations can easily pull it towards themselves away from the true center of the bulk of the points. Say consider these values. This point at the extreme end is an outlier that might pull the mean away too much. One way to rectify this is to first trim away the extreme points and then compute the mean of the rest. This is the same as attaching zero weights to those discarded extreme points. Depending on how far we trim, we have different versions of trimmed mean. For example, 10% trimmed mean or 5% trimmed mean. A 10% trimmed mean will first discard the most extreme 10% of the points, 5% from either end, and then compute the usual mean of the rest. Suppose in our example, we trim off 2 points from each end and compute the mean of the rest. We have trimmed out these 2 points and these 2 points and compute mean of the rest. Now the outlier can have no effect. Well, let's look at the computation using LibreOffice. Okay, so this time we are working with a real data set, not a toy data set. It's obtained from a survey, a sample survey conducted in one district of a state in India. Now, the first thing that strikes us is the plentiful variables. There are so many variables here. We have to first find out the variable that we want to work on. We want to work on the variable called land possessed or land owned. So this is the variable that we are interested in. Now when there are so many variables and you want to work on only a small subset of them, in this case just one, it's a good idea to copy it to a different sheet. So I will select it, Ctrl C, and then I will open a new sheet by hitting this little plus over here, and I will hit Ctrl V, and that gives me a separate sheet with my variable. I want to compute trimmed mean, for which I have to first sort them. Okay, so it's already selected. Now what I am going to do is I am going to sort it, go into the data menu and then hit sort ascending. So everything is now sorted. Now just observe one thing. Now one thing is that this heading doesn't get sorted, so it understands that it is a heading. And if I just go all the way down, I will notice something. It all the way goes on and on and on and on and on, and it comes here. So you see there are lots of NAs. So these NAs correspond to data not available. Not that this string NA has any special interpretation for LibreOffice, it is just a string. So this is not numeric, so it will not be included in the data. It should not be included in the data, though there are so many of these NAs. All that we care about are these 365. So there are 364 valid cases. When we want to compute trimmed mean, we shall focus our attention to only 364 cases. For these, we do not even have the data. Okay, so now we want to find 10% trimmed mean. So 364, we have to work out 364 times 10%, that is 1/10, and I want to trim half of this from this side and the half from the other side by 2 once again. So that gives me 18.2 rounded off to 18. So I am going to skip 18 observations, 18 cases from the very top and 18 cases from the very bottom. So let's just do this. It is 365, so I will skip 18. So 365, basically if I count 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. But that's very irritating. So what I will do is I will just do a little computation. 365 minus 18 plus 1, because I am counting the 365 thing. And that is, in my case, let's say 348. So I will go into 348. Fine. And from the top, I will skip 18. So I will go into case 19. Let's see where case 19 is. Here is case 19. So I hold shift down and click. So everything is selected. So I have selected the bulk of the data. And how do I compute the average? Well, in this case, I can see my average directly in this status bar. The average is 86.533, or I may just compute it separately. But since here I can get it anyway, I really do not need to do that. Okay, so I get 86.533. That's my 10% trim mean of this variable.